is that for fractions in general. I just wanted to give you guys an intro because I want to talk to you about rational expressions. Rational expressions are just fractions that have letters in them. Ta-da, right? Very scientific explanation. But if we apply everything that we just learned, it's the exact same concept. So check this out. If I have 10x divided by 25x squared, and this is why I like the factoring part of it, all right, the factoring version, I can rewrite this as 5, because this is 10 times x, right? And we know that this is 25 times x squared. So we can rewrite this as 5 times 2 times x. And that's it, right? And we can rewrite this one as 5 times 5 times x, because x squared is x times x, right? Now, one of these 5's will cancel out, one of my x's will cancel out, and I'm just left with 2 over 5 times x, which is just 5x. Bam! Done! That's it. That's how you simplify a rational expression. Now, what happens if you're subtracting them, right? Ooh, super scary. Check this out. If I have something like really nasty, like 4x over 3y minus 7y over 3x, you're like, I'm gonna throw the pen away. I don't care. This is crazy. No, it's super easy. Remember, you're adding or subtracting, you have to have the same denominator, right? So the denominators are pretty close. They both have 3, right? But they do not have the same variable, which is just a number. This is one number, and this is a different number. That's it. This is just 3 times y, number whatever, and 3 times x, which is number whatever, right? Another number, but still a number, and it behaves just like a number. So what do? We multiply on this side times x, we multiply on this side times y, and then we have 3 times x times y and 3 times x times y. Ta-da! But remember, gotta do it at the top too, right? And now we have 4 times x, right? Or x times 4 times x, whatever. It's 4x squared, right? 7 times y, 7y squared, right? And then at the bottom, we're gonna have 3xy on both, because x times 3 times y is the same thing as 3 times x times y, right? Commutative property, right? So this is 3xy at the bottom. Now we have the same denominator. Boom. 4x squared minus 7y squared over 3xy. That's your answer. Big, all scary number. That's it. Now what happens when you're multiplying or dividing these big monsters? Something like 2 over 7. You're like, ooh, no x's. That's okay. But what about if it's like x plus 3 over x? Ah! Multiply straight across. Same rule. Same rule. This is just a number, right? But keep in mind that you're multiplying by the whole thing though, right? You're not just multiplying by the x, you're multiplying by the x plus 3. So all we got is 2 times x plus 3. Bam, all of that over 7 times x. 7x. Done. That's it. Now you can distribute, obviously, if you want to, because the 2, we can multiply the 2 times the x and 2 times 3. So that would be 2x plus 6 over 7x. Bam, done. That's it. Now you're probably thinking, well, but there's an x at the top and an x at the bottom. Can you cancel them out? No. Because in the previous exercises, we were multiplying, right? Because if you multiply by x and then you divide by the same x, right? Or by the same number, regardless of what it is, then you're just really multiplying by 1, right? Like, for example, if I have 4 times 2 and then I divide that times 2, well, that's just 4, right? Because that is 4 times 2, which is 8, divided by 2 is 4. But if I had 4 plus 2 and I divided that by 2, is that gonna be 4? That is 6 over 2, which is 3. Totally different number, different operation. We cannot do that. This is a sum. You cannot do that. If they were being multiplied, by all means, but they're not. All right, and because 2x and 6 are not like terms, you can't add them either. So you just leave them at that. Bam, done. Now, if you were dividing, let's suppose that you had x squared over 2 divided by 4x over 5y. Now you're like, oh, 2 variables again, what the heck? I don't care, it doesn't matter, it's still a number. It's just a number, right? So this is just going to be x squared over 2 times 5y over 4x. So we have, now they're all being multiplied and divided, so we can cancel out now, right? We have x times x, which is x squared, x times 5 times y. All of that divided by 2 times 4 times x, right? We could split the 4 into 2 times 2 as well, but there's no 2's at the top, so I don't see the point in doing that. But yeah, this cancels the x's, and now we have 5 times x times y, which is 5xy, divided by 2 times 4, which is just 8. Wham, bam, done.